Hi, welcome for the second episode of Replica. Let's talk robotics, AI, and beyond. We I'm happy to have Sahil Kumar for our next guest in this episode that I've been doing because the purpose is to bring robotics engineers and AI engineers and bring their experiences with the work. This one will be about space robotics and robotic software engineering. Sahil Kumar, thank you for being with us, and I appreciate taking from your time and talk us about your experience as a robotic software engineer. And we're going to be talking about topics on space robotics. Thank you.
Mhm. It's great to be here, Miguel. I know I think we've been in contact for like a year and
Exactly.
a half, and it's super fun to be able to talk about these things, robotics and engineering in general, which I love. So it's gonna be really fun.
Yeah, it's fun. I love about these topics because what we at least with this one we're gonna talk about the future because robotics is being implemented now and they're talking about robotics in Earth, but we're talking about space. So robotics we're gonna take us to places like we never can be imagined, like exploring new planets,
Yeah.
exploring new things in like making a base in Mars, making houses or who knows that we can do in other planets with the help of robotics. What I want now is like if you can give us a background of all your experience in robotics so people can know you better.
Right. So to give you my background in general, I did my bachelor's from electronics and communications engineering from India, from Bharatiya Vidyapeeth College of Engineering, and then I came to New York to study mechatronics and robotics at NYU, and I completed my degree my master's about 1 year ago, and I specialized in mobile robotics. And right now, I am a robotic software engineer at a stealth mode startup in Houston, Texas. So yes, my journey to being just an engineer began all the way back when my mom got us this thing called an electromagnetic set, which was nothing
Okay.
more than a bunch of wires and motors and batteries which you just connect to power something up. And we were really young at that time, and I really enjoyed doing working with those. So that's where I started. And the reason that I like to talk about robotics in general, it's an amazing field in the sense of it actually encompasses a lot of things. But at the end of the day, for someone who's as lazy as I am, if a robot is doing something that I don't want to do, then that's fine with me.
Yeah, it's like yeah, we're when we think about robotics, we think in the movies of these
Mhm.
helpers in the house that they can clean the house, or they can do the food for you, like they do everything. So, but robotics can be applied in many areas.
Oh,
Like
absolutely.
yeah.
Absolutely.
So right now with COVID-19, there's some companies working with robots in some hospitals
Yeah.
that they do disinfection.
Hmm.
And now in mainly in China, they're being applying a lot of robotics because you can find helpers in the restaurants. You can find in a lot of places.
Hmm.
Uh,
Hmm.
but when you came from India and then you arrived in New York in NYU, what were the things that you start studying there? Like
Right. So when I came to NYU, I started studying mechatronics, advanced mechatronics, mobile robotics, robot perception.
okay,
In general, to give you a general gist of what they helped me understand, from the first day I stepped into NYU until my graduation date, I knew enough that I didn't know before to make an entire robotic manipulator that is able to use a camera to understand the environment around it using image processing and is able to move around smoothly, which is, you wouldn't believe it, but that's actually a proper technique that you need to do. Otherwise, the robots, they can actually end up breaking themselves. And I was able to understand that and how to make a bunch of different manipulators or robots work synchronously with each other without really one of them telling all of them what to do, but all of them telling each other that, oh, I'm here, you need to be here. I'm here, you need to be here. And all of that, and how to code it. And because I'm an electronics guy, I could even design the PCB and get the PCB made and solder it together. So yes, and NYU helped me in that sense, that I could make a robot that's able to look at its environment, process it, and synchronize with a bunch of other robots that are doing something similar and move around in a similar pattern. So in that concept of, like you mentioned, the, like we have today, the robotics 3D printing. And so even in those, you can have, from what I've understood so far from the topic of swarm consensus, that you can have a bunch of different extruders or a bunch of different robotic arms 3D printing things at the same time, but it's actually one giant 3D print that they're printing different parts of.
So that was the moment that you start doing 3D printing? When you started working with this?
Well, yes, I started doing 3D printing after I came to New York, and we had the makerspace, which had a lot of 3D printers. And of course, the thing was that so many people used to use them that most of the times they just like, you'd come back 2 hours later hoping that it's fine, and then your 3D print didn't even start, or your 3D print started and it's completely broken. So those moments when I would come down to the makerspace after hours of giving a simple 2-hour print and seeing the perfectly built 3D print right there for me to take, that was
nice.
Yeah.
Nice.
So then when I came to Houston, I decided to just get a 3D printer of my own.
When was the first time, like when the first brand that you like, what is the brand that you have now? Because you have a 3D printer, right? What is the brand?
Yes, it's right here. I think I can show it up there, hopefully. I don't know if you can see it.
Yeah, I see it.
This is a 3D printer right here, and this is the print bed. So this is a Creality Ender 5. And the reason that I got this is because of the giant print bed. And my brother actually knows someone who has like 3D printers at home who's a pro at 3D printing. So he suggested this one for giant prints. So its size is big enough that I can print, like, let's say, an Iron Man gauntlet in one go, the whole thing.
So what things in robotics have you been printing in this one?
So for my projects, I have started small because I did get this printer a few months ago. First, I was getting all the Thingiverse stuff out, just the funny things that you can print, 3D print, see how it looks like. But in robotics in general, I have been printing a case for my NVIDIA Jetson Nano. I have been printing a chassis for that same NVIDIA Jetson Nano. It's still a work in progress, but other than that, I'm making more designs now in like SolidWorks, in SolidWorks, that I can use in my ideas that I have for designs and what sort of a robot I can make. Because when we say robotics, there's a lot of different kind of robots you can make, and I have an interest in a lot of different ones. And there's half of those are in software entirely. So I do that for fun, and then when I want to print something in 3D, I just design it on SolidWorks and I put it on 3D print.
Nice. When you was in NYU, that was the moment about this project that you name it Army, right? That was the moment but that one is still in design in SolidWorks, right? But you never did 3D print that one, or you 3D printed? You 3D print that one?
I didn't 3D print that one. That was a SolidWorks because it was in New York, and that time I didn't have a 3D printer. And the 3D printer you never got time on them. When you did, they didn't work well enough. I mean, they were great because they were free. And anything free is, you shouldn't complain if it's free. That's my belief. But yeah, so now I can, and now I most likely will.
Okay, nice. So talking the topics in robotic software engineering, what are the first small projects that you start working as a robotic software engineer?
So as a robotic software engineer in general, in school, in NYU, I used to work in, I had quite a few projects. So one of them, like this is my master's project, was just,
what is that?
This is a 3D printed test bed for it. Not a test bed, well, this is a small version for it, which was for, for people who want to do physiotherapy.
Okay.
while they're at home. So you can see that this is a small version of it, and you can see there's an encoder here. As
Okay.
what it essentially does, it checks the rotations. It
Nice.
tells you how much this is rotated. So the idea behind this was for physiotherapy while you're at home. So let's say, God forbid, something happens to you, right? And you need physiotherapy to go and get it fixed. But you have to go all the way to the doctor's office. Instead, you can do it at home. And it's called telerehabilitation. And it's actually a booming field. So this is something that will help you with telerehabilitation. And this would be much bigger. And you would be able to stand on this platform right here and lift this. So it's, let's say it's an injury with your arms or your biceps or triceps or your forearm. So you would need some physiotherapy that would ask you to, the therapist would ask you to move it up and down and up and down, right?
Yeah.
And do a bunch of different exercises with it. So you can have this record that data, send it to the physiotherapist, or they can do a video call with you and show you, see while you're doing it and tell you what you're doing wrong. And the part about this that I really enjoyed making, well, I couldn't make it in real life. I tried really hard, but I couldn't get it to that level.
Okay.
Was using what's called ferrofluid. I don't know if you've heard it, but using ferrofluid to have and putting it all the way here. What ferrofluid is essentially oil with iron filings in them.
Okay.
So, sorry. What that would do is, if you have an electromagnet here and here that turns on when you give it electricity, it would turn on, and all the ferrofluid, well, the density of the ferrofluid, that was something that I thought of and tried research as well, would go to these locations. Like most of the density would go in these two locations. So this would automatically become lighter for you to lift and drop. And the heavier your therapist says, oh, now you can practice with heavier weights, the magnets over here would turn on and here would turn on, and the ferrofluid would come in these two places, and this would become slightly heavier. So the more the density of the ferrofluid is, like the spot, if it's here, it would be the heaviest. Then if it's on both these sides, it would be lighter and lighter and lighter. So that was one of the projects
So that was the first, like one of the first one that you work. Like
this was my master's project. That was a physical representation. Army was advanced mechatronics, class of advanced mechatronics, and I wasn't able to 3D print it, but I did use a lot of acrylic to get it done. So acrylic, I don't know if it's a form of, I'm not sure if it's a form of plastic or what, but
yeah, acrylic,
So
it's
I
the thing that they use for the basketball, for the right.
Exactly that one. So we even had that available at the makerspace, and the best part was there was this giant bin where all the discarded ones were kept, so you could just take those for free, and they weren't so I usually used most of those, and sometimes I had to spend a little money, which was fine. But I used that to make a small version of Army, and a proper version of Army, which was pretty big. And I used a Raspberry Pi, an Arduino, and a parallax propeller to be able to move those two robotic arms around and actually get them to give us a proof of concept of what Army can eventually be, which was automated robotic manipulators for integrated engineering. I came up with that simply so that they could spell Army.
Army.
Right.
No, but this project is being evolving, right? Evolving, like it's like first you have this concept about Army, and then you start like seeing other things that you can do with Army. Like Army can be applied to on a space exploration environment too, and that's something that we're gonna show to the viewers at the end, and how did you work that in SolidWorks. And we're going to show the parts in the process, so they can learn to what if they can do it too. Because at the end we're going to add this information in the description, so you can go to the links onto your website, because you have a website, and they can see how they can apply it too.
Right. And yes, as in the sense of the robotic software engineering, that is one of the projects that I really enjoyed making. And even the applications of it, every now and then I think of those and I think, okay, I have to get this somehow to work. I have to get it to like the point where I can actually make a proof of concept again and get it to that point again where we can do a bunch of things. But SolidWorks helps me visualize. I mean, 3D modeling basically helps me visualize how this would look and how cool it would look at times as well.
No,
But
yeah.
like we've discussed before as well, robotic software engineering in general can have just completely software as well, which was another project that I worked on, which was just a neural network, a basic version of a neural network.
What about that one? Can you say a little bit about that one?
So it was a neural network that was used masked RCNN for semantic segmentation, and what that basically means is it was image processing, and it was a very basic version of it because I was still learning about it at that time. Right now, I have more knowledge of it, but I'll still take some more time to actually build my own properly. But essentially, that neural network would help cars in identifying traffic signs, which is really simple. That's been done quite some time ago. But my original plan was that your car would use a neural network to use your experience as a driver, wireless driving. Of course, automated cars right now are brilliant and they're really good in just doing these sort of things. But the reason that I picked that was because as an experienced driver, you already know what's going to happen. You already have a sense of what's going to happen, right? I mean, oh, the trees are not going to move, but you know that the idiot on their phone at the light, even though it's red, they might move. So you have that sort of experience where when you stop a car or when you're going through a traffic light, you know where your priorities are, where you should be looking first. And then I can look, in front of, first I look at the road. If that's good, I look at the sides. I look at the people that can possibly come into my way. So I need to be careful. And then I look at the trees and the actual environment. So that's what I want to design with that. And that in certain senses can also be called robotics because at the end of the day, you're still automating it. But the best part about that about neural networks in general is that they're basically modeled after humans. So the same way you treat a neural network, you build one, you'd model one. It's very much like how you treat a child. In one way, a neural network can be created like an actual child, like in the sense of you show a child a car and you say it's a car, right? And you have to show the child multiple cars for them to say, okay, next time they see a car, they can say that's a car, right? That's how we learn. That's how it all works.
Yeah.
So if they say, oh no, that's not a car, that's a motorbike. You say, no, that's not a motorbike, that's a car, and that's why it's a car. So you tell them when they're wrong and you tell them what's right, and then eventually they'll automatically know that part. They'll be like, okay, that's a car. And in the broadest sense, that's how they work. And that's one of the beautiful things I love about them, because you can just make one and it will think on its own to a certain extent. Not too much, but to a certain extent.
So taking you back about the Army project and the 3D printing. 3D printing is something that is going to be using in space. Like they're talking about now in the 2024 with Artemis going to the moon, and they're talking about doing a moon base. And
Right.
the moon base is going to be 3D printing. And they're going to use a robot with the 3D printing inside or something like that to start building it with the regolith that is in the moon, because it's like taking the dust, the regolith, and mix it with some type of something, a chemical 3D printing something, and they're going to start building it. So if we take Army to that situation, how can be applied and what things can do?
Right. So yes, to give people more of a context, Army is the project that I also have on my website, but now I'll actually show you the basic essence of what it was and what it is. And it's actually a newer design for how you can make robotic manipulators. But what I'm using here is going to be partially like the half of what Army in its entirety is. But this was something that I was working on after our conversation, and I was super motivated. Like, okay, yeah, we were discussing about space robotics and was like, okay, I have to make something that makes sense with this. So of
Are
course this,
you're going to share something now with us?
yeah.
Okay.
So of course, so this is not the final version that I'm saying, oh,
Okay.
it's going to work perfectly, but
Okay.
it's a really fun thing to make. So let me see if I can get that. Yes. Okay. There we go. Can you see it?
Yeah, I can see it now.
Mhm. So this is the entire mobile robot that you can use with the help of Army. Army is these robotic manipulators
Mm-hmm.
right here. So, like I said, automated robotic manipulators for integrated engineering. What this means is there's something different than the usual manipulators we have with Army that I think we can use in a lot of cases, not just space robotics, but in general robotics, because we have a hollow body here. Now, if you go and look up robotic manipulators, most of them have a solid body. We're talking about the Kuka, the Puma. There's a bunch of different ones, and that are standardized in the industry. They all have a solid body, so it's impossible for them to go through themselves. So by that, what I mean is if I am able to move it, I can move it all the way down. Let's see. Um, okay, now it's working. My SolidWorks takes a long time.
No, it's okay.
So now you can see, of course, I still have to get the mating correct in SolidWorks, and I'll talk
Okay.
about that a bit as well. But in general, you can see how if it wants, it will go up as well as it can go down.
Nice.
So now,
Can you explain like from the beginning, like what are the parts
Mhm.
to build it, and what parts are 3D printed? That can be this whole thing can be 3D printed, the whole thing, or there's only parts.
um, we can try, but there's a lot that goes into. There's a difference between making something that's just for SolidWorks and for 3D printing. So to give you the short answer, as it is right now, you can 3D print it, but it will not move at all in real life. So, but if you print it correctly, you can either do two things. The first is you can print all of these components separately, and the second thing is you can build the components as that. You can just print this whole thing as it is, and it will move when you 3D
Mhm.
print it, and you don't have to do anything. Those are called print in place 3D prints. So you don't have to do anything, and they'll move because you gave them the right tolerances.
Okay.
But for that, you need to understand what your 3D printer is and what are its capabilities and what it can and it can't do. So, for example, in the case of this design, everything is just combined together, which is good because SolidWorks allows you to mate these components with each other. So you can say, oh, this component needs to move around this component. This component needs to move around this component. So you can do that, which I'm doing right now. But for a 3D printer, it needs a bit more to say these two components are different. Like right now, to give you a close up, this shaft and this wheel,
Yeah.
there's no difference in their size whatsoever. They're the exact same diameter. So my 3D printer will take these and say, you know what, this is actually one piece, so I'm just going to print them as one piece. That's it. However, if my shaft is smaller in size or the shaft hole is larger in size just by 0.2 millimeters, which is the resolution for my 3D printer, it will print them separately. So right now, I can even show it to you, like render it, but it's going to take, not render it, but the small window, I can render that, and will take a minute to render it. And while it's doing that, I'll show you what it will look like when you try to 3D print this. So this is what I had open here before.
Okay.
So you take that design and you tell, and this is 25% of the actual size of it. If I tell it to 3D print it right now, it will take 6 hours and 30 minutes. These are all the supports it will have. Is it done? Oh, it blinked. I thought it was done. These are all the three supports it will print, but you can you see these lines? I hope that's clear in the.
Yeah, I can see it.
So this is my extruder's actual extrusion. So because it's so small and these component, the chain link was so small, if I print this, while there are components that will be perfectly fine, like this will not be that bad, this wheel will not be that bad, but these chain links will break as soon as I try to break the supports. No doubt about that. But you can.
That should be in a large scale because this is like small.
It should be in the large scale, or you can print components that are larger. Like if you don't print the chain link, everything else will still hold up fine. But this chain link is the part that will quickly break up, like really easily. But this is, oh, by the way, this is the Ultimaker Cura. This is what you use for taking your 3D model and putting it in SolidWorks, putting it to the 3D print. So yeah, if you do this right, you will end up basically like Iron Man, which was one of the things that sold me on this. Where, and I've done this by this point. You think of something, you design it quickly, you design a 3D model in SolidWorks.
So
give it for
so these parts that you're showing here, like what are the parts? Like I think I asked you that. Like can be print. Like can we print the wheels, the whole thing?
Right. So you can print all of this. You can print all of this.
But
you
there
can
are
print
the parts that you need to do
together. That's up to you. But of course, given the right tolerances, you can print all of this and combine it in real life, and it should work.
Combining, okay.
Yeah.
So what situation these can be applied? Like one thing that can be applied, like getting samples or like building something, or like what you can do with this.
So my idea is that you should be able to do all of those things using this robot. I'm still yet to name it because I want it to be something really catchy. But with this robot, you can, in my head, you can do a lot of things. So the part about it that's different than what we already have is Army. Mm-hmm. And the part that's different about Army is it can go from
that's here, Army on the top.
Mm-hmm. So this manipulator design is Army. Mm-hmm. And so the actual Army has a smaller arm between as well. And both of those large and small arms, this whole larger arm and that smaller arm would coordinate with each other on what to do. So in a regular assembly line, the smaller arm would be facing the other way and this larger arm would be facing this way. So the smaller arm can do something here, the larger can do something here. However, in this case, the first use is, let's say it's a terrain that requires train tracks, right? That requires the caterpillar tracks that we have here. So all four manipulators can either be in the chassis or they can be facing up. If they are either of those things, I mean, if the terrain is like that, then sure, the robot will move. And if we have any samples to collect or we're 3D printing on the side, of course, they're only facing the inside the chassis right now, but they can be designed to be facing outside as well. So if you're 3D printing something, so this can be sort of like a tank that's going around the 3D printed, 3D printed, let's say, dome or hab, and extruding as it goes along. But if it's a terrain that and of course, collect samples as well. Just go around, collect samples from wherever you can. One arm can be the drill, the other arm can be the gripper, and you can do that. Or if it's a terrain where the caterpillar tracks are not the best option, well, you can use Army and you can take this down and this down as well, like the ones that are here, and use them as legs.
Oh, nice.
So all four of them would become legs, and this will then move like the dancing robot I'm sure you would have seen from Boston Dynamics called Spot.
Yeah, like the Spot, yeah.
Yeah, so
it's like, it looks like a dog or like, yeah.
Exactly. So this would be able to do that and move around in those tight spots. And then when we're talking about tight spots, let's say there's a cave or there's a 3D print that's gotten to the point where you have something like this on both sides of the wall. So we can 3D print a wall, and inside it's hollow, but it has two sides, right? And inside you need to fill and you need to design on the inside. Well, all you need to do is have these slots in the wall at different distances from the top. And then these chain links and these wheels will automatically fit inside those slots. And then when you move the robot to go forward or backward, it will move forward or backward at that level. And then you can use these as extruders, these arms as extruders, to 3D print while it's moving in between the wall. So that can be something as well. So there's applications that you can, that there are a lot of applications.
So we can share links for the viewers so they can like try this and they want to test it and like they want to do something with it in your website.
Absolutely, absolutely, absolutely.
Yeah.
I really enjoy SolidWorks as like a free time thing. So even just passing time on it. So for me, this is like, yeah, go for it. Go ahead.
Yeah.
If
So
it's helping you in any way to get better or become a better robotics engineer or just a general engineer in general,
great.
then it's fine by me. It's fine.
No, and I want to say to the viewers that at the end we're going to take Q&As, anything related that you want to ask about this project Army, and all the questions you can put it on the chat, and we're going to answer at the end of the event. So about there's other project that you have, right? Or is a small project that you like doing jet engines or something like that, right? You was
Right,
telling me.
right.
So can you show us a little bit about that one?
Right. So let's see if I have that here. So the jet engine was just something that I've started doing recently, and it's a jet engine that I designed in SolidWorks by looking at an instructional video on how jet engines work.
That can be 3D printed, like can be
3D printed.
3D
Yes.
printed. Yeah.
Right. I have it 3D printed, but just today in the morning, the show will always go wrong. There's a saying, right? So today in the morning, that 3D print broke. But let me show you what the 3D print looked like, and I'll show you the pieces in real life as well.
Yeah, show us something. Yeah.
So
you're gonna share, right?
Let me cue that up here, and in the meantime, I'll show you the actual, like the physical version.
Yeah, it's a small model, right? So you're gonna show us like the big thing, like can be done. Okay, good.
So right now I'm putting it on. It's gonna take a minute to render properly.
No problem.
So
let me know.
These are the components for it. So these were all printed separately. So for example, this fan was printed separately. I don't know if you can see it. Yeah, this fan right here was printed separately. Then this is the first compressor stage. Yes, this is the first compressor stage that was printed separately. This is the second compressor stage that was printed separately. This was the final, I think it's the turbine stage that was printed separately. And then, well, it was like this in the morning. Like today morning, it was like this. And then you have the outer casing for it, which is right here. So you just put it in the outer casing and you combine all these parts together. And then you have the final stand for it, which is right here. So on the stand, you'd place the whole jet engine, and you can see it says jet engine as well, which is just...
So that's something that if someone can want to build like those parts in a large scale,
absolutely
can be done.
Yes.
So it's the whole process, and you can put it on. Yeah. So let me know when you're ready.
Yes.
To share.
Make sure I am a bit lazy, so the dimensioning on these is definitely off. No doubt about that. But if you want to like just print for fun, I'll put this design up as well. And I think I've almost put it up at Thingiverse as well. So you can just go and I'll put the link on the...
Yeah, that's my purpose with these live events. So people can learn something and they can take something with them. Okay, let me share the screen now.
Yeah, there we go. So this was the... I don't know why this is not rendering. So essentially the stand is underneath, but this is what it would look like.
Can you describe the parts like put it like the better?
Right. So for that, it'd be quicker if I just turn off the rendering. So this is the entire design, and the different parts are. This is the fan right here.
Can you close up a little bit, or like put more like open, so people can see it better? Okay, good. Okay, no, that's okay. Okay, good.
This is the fan. This is one separate component. So the cool part about SolidWorks is I can just change transparency so you can see the rest of it. So this is the whole component. And internally, you can see there's a small cavity for the first combustion stage to actually go. And then this is the first combustion stage. sorry, the first compression stage. Now you see these protrusions that I have that you also saw in the real model as well, the 3D printed one. These are also, like I said, you need to know your 3D printer before you 3D print. So if your printout is small enough or your resolution is not good enough, these will not print out correctly, or these will print out crooked, or they will not be of the rights, like they will not look good at the end of the day. But so that's something you should also take into consideration when you're printing. And then I can change transparency here. And now even this is transparent. Now this is the second compression stage. And I've also put in the fuel, I think it's called the fuel ring. I forgot the full name of it, but this is where the fuel comes in from. And the way that it works is the air goes in here, it gets compressed. And then here, that air is mixed with the fuel that you're sending in. And then the compressed air is already hot, and now you're setting it up, you're firing it up, and then that hot combustion goes through the rest of this, which is the final combustion stage, as I have named them. Like those are actually the names, but I don't think that you can call the entire thing as the compression stage or the entire thing as the combustion stage. But so yes, these are the different components for it, and you can see how they all fit together. So in this case, you can definitely do the same thing. You can 3D print all the separate components and put them together in real life, and it will be fine.
Okay.
If you want
to.
Mhm.
From this project, what other things can be built, like or can be attached to it, like this jet engine, like
Right.
for space related?
So this is a general jet engine. Like this is just the engine that's
Yeah,
used
it's
in
normal.
planes and jets right now. So that's the normal version. But the idea behind showing, like my thought of showing it today here is that you can not only build what you already know, but you can also build what you want to imagine. So in this same concept, you can improve it. This is the regular jet engine. You can improve it and think, oh, maybe this might work in my application. Maybe that might work. And then you have in SolidWorks, you have a bunch of tools for simulation and general tools to see how it works and to see how well it would stand the test of different things. So, for example, there are mechanical vibrations with any assembly, right? So if anything is wrong, like in this case, anything is loose, you can have vibrations that are so extreme that they can end up breaking some components and it stops working in entirety. Then you want to see how the air is flowing inside. You can do that with the simulation as well. So you can do a lot with simulation in SolidWorks, especially. But of course, there are even better tools to be able to do that. Right.
So you're telling me about the Army project, and you told me about this one jet engine. There's other ones that you can say like because your interview with Replica, you're telling about some patents that you made or like in India, right? Or no?
Well, those were provisional patents that I filed, yes. And yeah, I mean, to talk about them, it was very, very interesting to try that.
Okay. Your
Because
experience and how you fill it up and like the whole process. Okay, you can tell us about the process that people can learn if they want to do some patents.
Right. So here, I do believe it's going to be much trickier and different. But in India, this process is straightforward. You have the website of the intellectual Indian Patent Office. I think it's Indian Patent Office, or just search IPO, and you'd be able to find India's Patent Office website. You can go on there. There are certain set of forms you need to find and fill. For all of those who are in college right now, you probably have an intellectual property office in your college, or intellectual property department in your college, which was in my case as well, who will have people who get you all the forms that you need. And the fees is also not a lot. It's very minimal. And if you're doing it from your college, the college will, in my case at least, the college paid for it. So the process in its entirety is, the first part is you can either put in the whole patent together at once, or you can file what's called a provisional patent first. And then you have 1 year to file the claims. So the way that the provisional patent works is you give the forms and you describe your invention in general, like the gist of it. The compared to the claims, that's just the gist of it. Like, okay, this is what I want to create, and this is what we will have. This is the thing that we'll have, and you have to make sure that it's something that's patentable first
Mhm.
off. So this was something great. My professor helped me understand, where that component or whatever you're making, it cannot just be a combination of everything that already exists. So if I say, oh, I made this new, made this new robot that's nothing more than an NVIDIA Jetson Nano in a small chassis and 4 motors, unless it has a really specific application, and then that goes into different kinds of patents that there are. But in general, it has to be something that's not obvious, and that's even described in the patent law as well. That it has to be something that's not obvious. So if I'm saying that my car has an indicator to go left or right, and I'm adding another indicator that's indicating something else that's not really that different, then I cannot patent it. That's going to be something that's just going to reject immediately. So you have to first see if your idea is patentable. It's not something obvious, and it is something novel. And you can, loosely said, you can use everything that's already existing, but it has to be then making something that does not exist or is very unique, or depends on what kind of patent you get. Once you do that, you file the provisional patent. You have 1 year to file the claims. After that 1 year, within that 1 year, you will file the claims, which are going to be more specific towards your invention. And that's another point in patents, that you need to be really specific. You need to be really specific. And at the same time, general. It's a very weird line to balance, but you have to be specific so that the patent law office can say, okay, you want to do something like this. But it has to be general enough that someone can't just make a spin-off and make something themselves, right? They cannot just change one small thing and then say, oh, that's my patent. So you have to be careful about that as well. Like, you have to cover your bases enough. Then once that is done, you file the claims, and it takes time. In my case, it took like 2 years for me to get the FER, which is called I think the first examination request, which essentially is, we've looked at your claims. These are the things that don't make sense to us, or these are the things that already exist, or these are the things that we do not agree with. Then you have to fight that FER. So that you can do with either a lawyer, like you will have to get some sort of litigation for it. And that depends on how you're getting it through. Like I said, if you're using it through the colleges usually help in that. Colleges usually help in you filing patents. If it's a good college, it will help you with intellectual property, and they can help you with all of this. So you just do that. You go to them, you tell them, okay, I got the FER, and hopefully they'll help you. Otherwise, there are other ways to fight as well. I don't know if you can do it on your own, but you can do that. And then if you want your invention to be not just in India, but other places as well, then you have separate forms for that as well.
And there's a website that they can go and find more information about this.
Yes, just go to the IP. Just search India IPO IPO website, and
That's
you'll
from, yeah.
find that's it. Yeah, it's the Intellectual Property Office or Indian Patent Office, one of those two.
So tell
But
tell
yeah.
me of challenges that you had when you was doing your career as a robotic software engineer, like challenges from you came from with the for the University of India and then you went to NYU, challenges that you had like that can help, that an advice that can help others.
Right. So there's a lot of things that I can talk about, but mainly it is, if you're coming from India to study and to work, then the first thing is you need to be genuinely interested in your field. So in my class of 60 people, there were very few people who genuinely wanted to do engineering, who genuinely were interested in engineering and wanted to. The others were just there, okay, I didn't have any other choice, or this was the funnest thing I could think of, or, my parents told me to do it, so I'm doing it. So the very first step is, if you genuinely want to learn, then definitely you can try coming here. That was one of the challenges that I faced, where in India, there were times where I came up with an invention for one of my projects, for all three of my projects that you have to give in a 4-year undergrad course in India in engineering, at least in my case, I came up with, out of the three of those, for two of those, I came up with my own ideas. Actually, for all three of those, I came up with my own ideas for my inventions. I was like, okay, if this works out here, I'm going to get an invention for it, patent for it. Other than the first one, the other two, like the second one, I remember one of the teachers even started laughing, like, what is this? And she was, okay, you know what? You did not make this project. I don't believe you because it's too well made. Because I made it so that, you know what, I can go to other people, show it to them. But like, no, it's too well made. So you will need that support as well. In my case, I got that from 4 people in my college. If you are from that college as well, they will definitely help you. There's Professor Arvind Rehalia, Professor Narendra Thakur, Professor Shefali Sharma, and Professor Vishal Sharma. These were essentially, what I'm saying is, find your mentors to motivate you. In my case, these 4 people constantly kept pushing me, constantly kept telling me, okay, file this, go to this event, go to that event. I'm sending you here. I'm asking you to lead this team with any idea that you have. Tell them the idea, they'll make it. So that's the very first thing. The second is you should have a story for it. I have seen chemical engineers here who went into robotics engineering. So when you're coming abroad, that's possible as well. You can do a complete switch from A to B, but you need to have a story assigned with it. You need to say, oh, well, I started here, and then in undergrad, I saw this, I found this out, and then eventually I got to this point. I remember going to these these fairs where the people would talk about it, and they would say, like, I don't care if you got a letter of recommendation from the president of India. We don't care. Our colleges don't care. What we do care about is we have a letter of recommendation from someone who knows your work, someone who's worked with you, who can vouch for your work. So when coming here, usually for each college, you need about 2 or 3 letters of recommendations and 1 statement of purpose. Statement of purpose is why I want to join this college, why I want to join this field, why I want to do anything here. And then the second thing is the letter of recommendation, which is your professors or mentors talking about how they work with you and what they liked about you and why you should be admitted to this program. Then when you're choosing the college, there's a separate procedure for that as well. There's different websites like Yocket, Ubergrad, and AdmitCart. These 3 are like the ones that I used. And they talk about, oh, these are the college listings by ranks. These are the people who went to these colleges. This was their GRE score, their TOEFL score. So there's a bunch of exams that you have to give as well. There's 2 exams, GRE and TOEFL, that you have to give to get to colleges in the USA. One of the major problems, which was surprisingly small, but it can become a major problem for me that I saw, was the visa interviews. I know a person who had failed 3 times in their visa interview in the first year, and they had to skip 1 year, and then the second year they came to US. And they were phenomenal. Like, they were amazing coders. I remember that guy. He was an amazing coder, but because of that, he had to be delayed 1 year. And why is that? Because the interviewer did not feel that this person was right to give the visa to. In my case, in a lot of cases, it was like that. They ask you a couple of questions, go ahead. But in a lot of cases, they need to see a lot of things. Of course, this is all speaking from my personal experience and what I know from the people.
Yeah, and that's good, and that's something that I want people, like, they're looking for that. That most like people from India, they're gonna go to US and they're gonna start with the robotics, doing robotics and working in that field. So when we talk about when you went to NYU and started working with robotic software engineering, what was like the first thing like came to you, like, I want to go in this field and I want to work with robotics? What made you feel like in that moment in NYU, because you was working in engineering in India, right? It was in like mechatronics, normal things like that, and then you start with robotic software engineering in NYU, right? So what made you go to that line and now doing the 3D printing and thinking of more projects like you're doing now, that you like doing things for like side projects, but like related like to space and doing those things?
Well, when I came to NYU, even in general, even before I joined electronics engineering, in fact, I wanted to build projects from the ground up. I wanted to be able to, take something in my head and from the ground up be able to build it. So the natural progression for that was robotics, because I already know, okay, how to make circuit, how to assemble a circuit, how to put the PCB, which PCBs to put on, what to do with that, how to code it in a basic sense. And I knew that the next step to that should be robotics, because robotics are very interesting when you look in the right places. I mean, like everything can be, a lot of things can be considered a robot. We ourselves are robots. In all sense and purposes, we are robots, who are doing proper work. And there are fields in robotics that are using nature as the motivation for it. So for me, robotics was about a lot of things. First one, of course, was just I'm lazy, so I like to automate stuff.
Yeah, like you say.
Yeah. And the second one is it can actually help people a lot, not just from taking them out of dangerous situations that they're working in, but also just in general, robotics can be really helpful to people. And robotics, by that, I mean, of course, I mean robotics as in automation in general. So that made me go on, and now I'm working in 3D printing and projects, because my original goal was always, like I said, I have an idea, build it from the ground up, see where it goes. And that was the reason that I had the patents as well, because there have been a lot of times where I thought of something like an invention and it was either already made, or when at that time that I thought of it and I started working on it, I worked on it for like 1 or 2 months, worked on it as in I thought, okay, I'm going to do this, I'm going to do that, I'm going to do that. But I didn't have the knowledge for it. I did not have that exact knowledge on how to do that. I just knew, oh, this is what I want to do. And I tried to learn from online, but I couldn't really do that. That was just a personal thing. But when I did that, 2 months later, I'm researching something similar online, and I find exactly what I'm looking for. What I thought I was going to make, someone recently made it, or I found the patent that someone already filed. So for me, it was like, that was another reason that I went into patents as well. So that the whole procedure is, I have an idea, I think that that's going to really work. I research online, I don't find anything that's like that. Then I create my patent, I file my provisional patent. 1 year later, I'll file my claims. And during that time, I actually design what I want to design and I make it. And then hopefully at the end of it all, I have an invention that's completely working, or at least a proof of concept with a patent. And my goal from that is to eventually be able to make my own company that, by selling my patents and my designs, and that at the end sells not only my designs but other people's designs as well, and inventions as well, that just make either life easier or life safer for people. And that's the end goal here.
And now that you're saying about safer and talking about space, when taking the main point on robotics is to take it to space, it's like going to be easier. They can build things there like the 3D printing stuff, and they can allow, they don't have to take it from Earth, like taking in a rocket or something like that. It's more difficult. So they can build it from there. They can use the resources there, and that's the main point. So, telling me about what you think, like what parts of robotics or what things in robotics is going to be very useful to make a better exploration and keep us safe.
Mhm.
With that.
Well, robotics, in the sense of space exploration, has at least, like, it's obvious how many applications it has that are just amazing. One of the funnest ones was, like, for me, that's why Interstellar is one of the favorite movies that I have. I don't know if you watched it, but the reason for that is that robotics, one of the things that it can do is, like, talking in the broad sense, there's the longevity of life. Like, we know that we have a average human lifespan is about 70 years, 60 years. It's going down, I think. So for actually going to exoplanets, or just going to different planets that we might be able to inhabit, we might be able to build or continue civilization there. Right now we're trying for Mars, right? But the closest planets that are even like remotely similar to Earth, I think that so far the closest is Kepler train 2b, and it's light years away from us.
There are
So
many. There are many.
yeah,
They're talking about Titan, talking about Europa, and like taking there's so
yeah,
many. Right?
yes. And even in those, the thing is that we the first thing is we cannot find what we were given, the beautiful earth that we have been given, that we've kind of messed
Exactly.
up basically completely now. So it's really difficult to find something similar to that. We can adjust and go to different places that are, but in general, space exploration would require more than the average human lifespan, at least from what we have right now. But eventually, hopefully, if we have robots or we have robotics that can help us, in one sense, we can go in the direction of, oh, we'll have robots that go into space, that go like the Voyager is going, go out of the solar system somewhere else completely, and then they have a lot of human eggs and they fertilize the eggs there, and the human civilization is born again there instead of taking actual humans there. Or you can have people who are cryofrozen. I don't know how viable that is by this point, but you can have that. And the third thing is you can have nanites that actually, I don't know, make sure that the human lifespan at least increases. Because the reason that we die in general is that our body keeps remaking itself, right? And eventually, somewhere along the line, like in 7 years, you'd be a completely different person. Your whole body would have replaced itself.
Yeah, 7 years. Yeah,
Yeah.
it's that.
But there's a point at which that process falters. I'm not sure if that's completely accurate, but from what I understand, eventually that's the process that falters that causes old age, decay, and death.
Yeah.
So even modern science, if it's to get to that level, it will need robotics. It will need autonomous things. And in space exploration, other than that, you have rovers. That we have I
Yeah,
think
robbers. Yeah.
the latest one was Perseverance, right? Or was it Curiosity?
Yeah, no, it was Perseverance.
Perseverance,
That
yes.
was, yeah,
Yes.
that's the last one.
So
Yeah, but there are many options there because they have the Pathfinder and they have Curiosity, and they have Perseverance, but they were continuing in a evolving because it was since 1997, and now the last one is now in the 2021, 2020, 2021. It was made 2020, 2021. So but it's you see from the first one it was a small robot, and then it's like started getting bigger. Now it's like almost like the size of a car what
yeah,
they have there, and they keep attaching things like now have an helicopter. There's a drone that's going around. There's other parts, and I'm sure they're going to continue doing things to keep getting samples, to know the air, because they're saying about Mars that is similar to the planet Earth, but it's not so similar. Like there's many things that they need to do there. It's the only thing that they need like is for habitat. Like you can do something there, but that robots is like for me, from my perspective, is going to accelerate all these things. That's for me the importance of robotics in space
right.
to make all these things faster and to discover new things faster. That will be like our other eyes to things that and the robots and AI. So those things is going to help make progress and do all the exploration in space faster and safer because we no need to risk something like human life in
Exactly.
the process.
Exactly.
So,
Exactly. Yeah, absolutely. And the thing with these, with robotics in general, is that it's all, to me at least, it's all about thinking the right way. Like any solution, any problem that you have right now, there's a good chance there's a solution for it. You just have to think about it properly. So
exactly.
with robotics, it's amazing. One of the things that I really liked that I think would be helpful here in this case as well, that I saw it at NYU. There was some research going on there about, and this is a proper field. You can have robots that are like a tube, not even an actual, a mechanical component. It's a tubing, and that's filled with air that has certain, I forgot what it's called exactly, certain degrees of freedom. There's a term for it because you cannot directly control it. You cannot directly control a tube filled with air and moving it left and right and forward and backward. So there's a whole field dedicated to that as well, where you control it properly. even though it's not controllable. So we're using that. We're using so many things. Like even in general, I remember there used to be this show called Men in White that I used to watch on Discovery Science. I don't know where it went.
Hmm.
It was. I wish it hadn't gone, but it was one of my favorite shows. And
What?
they did stuff like that where they I think one time they came up with this caravan which you take around on your bicycle, right? And the whole back of it is actually just cloth, right? Like a tent, like a really small tent, and it's like completely flat.
Okay.
The the bicycle actually had a dynamo attached to the back of it. So the more you bicycle, the more energy is created, and you use that energy when in the night you want to stay. So in the night you stop anywhere you want to stop. You have one air pump that's attached to the tent. You close that, you get into the tent, you close it up, you switch on the air pump, which is being completely powered by your bicycle from the morning. And then for the whole night, you can sleep in that tent. And that's similar to this because you can take just a piece of cloth, you can take just the air pump, and the energy generation is all on its own. And that can create your own hab, and you can just live in it. And of course, there's billion different complexities with that. But the logic here is that use robotics correctly, and there has to be some sort of solution to what the problem you're looking for. There has to.
Yeah.
There
Yeah.
has to.
And
But
there are many challenges that for robotics in space. It's going to take us to places, and we can fix many things with them, and when we take them to space,
mhm,
and but there's challenges in the weather, there's challenges in the surface,
absolutely.
there's many things,
Mhm.
and I'm sure that now when all these commercial space flights and when now the Artemis go to 2024 to the moon, we they're gonna be on top. Like they're gonna need many robotics engineers
Yeah.
to work on this. That they're gonna need more and more and more. So that's why I like about robotics that instead of like people seeing it in movies that because always movies take another story. Robotics is evil, like this, like they take like always like that's the part of fantasy.
Yeah. Yeah.
But I see it that they're going to help progress the humankind. Like
Absolutely.
they're gonna take us to the next level. AI and robotics gonna take us to the next level.
Hmm.
We're gonna take it further. And when we see like I'm gonna be there, I'm not going to be there because but when in the future that robotics will see like take us to discover these new planets and these new things and
Hmm.
explore better like
Hmm.
we're doing now with the rover and Mars and taking new things that we're going to see it that we're going to be part of our
Absolutely.
life in the daily life robots gonna be there.
Yeah. And that's the funny thing. Like like you said, like we talk about robotics usually when it's talked about, it's like, oh, the Terminator or some other robots that are killing machines who are doing.
Yeah, people
And
always talk about the Terminator or
uh-huh. But the
those
funniest
kind of
part
robots.
is the funniest thing is, see, the first thing is that even amongst other robotics engineers, I laugh about this. Like I'd say that the people who say, oh, robotics will take over the world. There's
Yeah,
people who say that all the
they're gonna
time.
destroy us. It's
Yeah,
gonna be
they're like,
Skynet. Skynet is gonna take
yeah,
over.
in 10 years. And one end, they're saying that. On the other end, in the DARPA challenge, we have robots that are unable to open the doorknob and they fall while trying to open the doorknob. And we say, okay, you're definitely far, far away from even conquering, even getting into the world before conquering it.
Yeah.
But the thing is that the most violent, not just violent, but bad AIs that you can see online, that we have seen in the past online, were trained on people. So there were times where they took an AI, they took it through everyone's Twitter, they made it go through people's Twitters and Twitter accounts and interact with people in general on Twitter. And within a day, it was the most horrible human being that it could be.
I remember that.
It
About
took
it. Yeah,
all
that
their
was.
parts and
I think it was Microsoft or something like try
uh,
that. I think it was Microsoft. I don't know. Like they tried something like with AI and then they need to shut it off because remember the thing about AI is it's learning. It's learning constantly of other things. So if you put that information of the other people reaction and how other people react, it's
Mhm.
gonna learn that. It's gonna be learn like to be racist. It's gonna learn to be violent. It's gonna learn like, and that's the thing that because it's learning by mistakes, and that's the
Mhm.
thing that's gonna come like learning and taking out.
So that's
So
it. Yeah,
go crazy.
if you have the right data points, you can train
Yeah,
the AI to
right
do a bunch of
information.
different things. Yeah, I can, like I said, the car example. If I show it a bike all the time, if I show it 1,000, a million images of a bike and tell it it's a car, then it is going to think that's a car. No doubt about that.
Hmm.
That's very basic because it's how it's designed. It's how we are designed. It's how we work. So really, it's not like robots. When we're born, we're essentially those same AIs. There's not a lot of difference. Only we are much more complex and we take on latch onto things more quickly.
Yeah,
But
we learn by mistakes.
yeah, you learn by other
That's the
people. You learn
process.
by mistake. If you were grown in a, you were raised in a hostile environment, or you were raised in a place where people were, like you said, like mean, violent, racist, whatever,
Exactly.
you will grow up to
That's
be
the
that person,
data that's gonna take.
or at least you. That will be your mentality. That's how you should be.
Mm-hmm.
There are people who say, "No, this is wrong. I want to be right." But for a lot of them, that would be the case. That, oh yeah, this is normal. This is how you talk. This is what you do. So with the
Yeah,
AIs, that will happen.
because that's been taken. That's the information that be taken from generation to three
Hmm.
generation, and like
Hmm.
keep passing by. So the same as the in robotics in the good hands, we can make great things.
Hmm. Hmm.
And the people that is behind those things, they're gonna take it to the next level.
Yeah.
Like
Yeah.
is there's so many things like taking into the healthcare, taking the elders, taking care for many things. So we're talking about taking jobs out and like people who not be. There's some task and like everything because like when came the industrial revolution, there were many jobs out.
Hmm.
So people need to understand that, and we're going to be always there. Like people
Hmm.
hating what is going to come next, what is
Hmm.
going to come next, because what they know until the moment is going to disappear. But instead of thinking like how I can embrace that next level, they
Hmm.
prefer because they get used to like, oh, I like this, I like the way the work is, I like to be working instead of thinking, oh, I can use robotics and I can have more free time
Yeah.
and the robotics can do things because that's the way they need to we need to see it. We need to see it like they're gonna be doing work that you can have extra time to do other things.
Hmm. But
So
like there's this. I for me, the slight difference in that is that I think that there has to be a certain balance because I've seen, for example, I don't know if you watched the movie Wall-E. It's really fun.
yeah, it's from Disney.
Yeah, and that's what they show in that. One of the things they show in that is people have gotten so lazy because everything is done by robots that they're just on their couch the whole time, on their chair the whole time. And the
Well,
thing with
yeah,
that is,
that's
but
happened now. That's happened now, and there's no robots, but
exactly,
robots
exactly. That's the
gonna
thing.
be.
That's the thing. You can put the knife in the hand of a person, and then it's up to the person if they want to cut vegetables with it or do something else with it.
Yeah.
That's up to the person, definitely. But with robotics, yes, it can make things easier, but beyond one point, to me, it's just like I didn't even think that this was an inconvenience. Like I'm fine
Hmm.
the way it is. Like for me, it's not robotics, but in automation in general. I think it was Amazon Go or something where they,
Yeah.
yeah, you go in the grocery store, you just pick up stuff, you leave. And for me, that was so weird because I constantly think like, why is this something of an inconvenience? Like I understand, maybe if you have an extremely busy life, you cannot do anything else. Maybe then. But to me, the logic is that this is part of life. Like this is something that you have to do. Like
Hmm.
in general, like you go out and that's how you meet people. That's how you have the life. Like if you choose to have everything done by robots or not do anything at all, even without robotics, and stay at home all the time, you
Exactly.
cannot have that thing. Like you cannot have a proper life because human
Hmm.
life is human interaction. There's a reason we are herders. We are always in groups. We are always in gatherings because we need other people. And if you take that interaction away, like sure, us talking right now is great, but it's even better if you're talking face to face. That's
Exactly.
always going to be there. There's always that interaction, but There's other people who have, let's say, anxiety with that interaction, who choose this other life where they just don't do all of that, any of that.
Mhm.
And I support that, the fear in that. But yeah, like there was this movie Surrogates with Bruce Willis. It showed it
Yeah.
perfectly. Everyone has a robot, everyone has a surrogate robot, and there everyone else is just in real life they're just sitting on their chairs and not moving at all, and the robots are doing everything for them in the world.
Yeah.
So I think
There's
there's a sweet balance, but
there's a
definitely,
balance. Yeah, it's important.
yeah.
Yeah, I feel like there's people that are gonna take that way, and there's other people that know that people that okay, this is my time to build other things or to do other things
Absolutely.
that is gonna be better.
Yeah.
But there's gonna be people like saying like, okay, it's better to stay now because if we take it like now, people ask for food to bring to the house and they don't do nothing. There's no robot there. There's only a person that you ask for a pizza and like, okay, go home and take it. So,
Yeah.
but in robotics, is
Mhm.
something that gonna help us be better. Like not like these movies, like
Yeah.
it's gonna destroy us.
Oh yeah.
So yeah, but the balance is perfect. You see the surgical robots, that now doing surgery is gonna helping doctors
Hmm.
to do all these things better.
There's even remote surgeries. There's remote surgeries. Doctors
Remote
can
surgery.
perform surgeries from miles and miles away with the robots. And there's also like a very simple thing that we don't even think about. Like with dialysis machines in hospitals, you need
Hmm.
to have a nurse that's constantly looking at the dialysis machine to make sure if anything goes wrong, they know how to fix it. In robotics, I think it's already done. I don't know if it's already done. I'm not sure. But like you can have something that's just looking at that machine at all times, and you're just, all of those machines. And if anything goes wrong, you just have an automation that says, okay, something went wrong, go check it out. So you can have one nurse doing the job of, let's say, 10 nurses who are all just standing next to the dialysis machines, waiting for something to go wrong. Instead, they just, one of them, have one nurse sitting at the desk. And as soon as one of those monitors pops off, it's like, okay, something's wrong there, let's go check it out. And that's part of what automation and robotics is about. But yes, it's kind of demonized in the sense that, oh, robots are going to take over our jobs, they're going to do stuff that we are doing, and then we won't find employment. And there's some credit to that too, I'd say, because there are people who just employ robots simply because it's cheaper. Like yesterday, I went to the car wash and I was discussing this with a friend. We had two people. We had two people who are just in the car wash. That's it. Everything else is automated. And we're thinking, I mean, that's great. My car looks super clean. But if you had more people here, that would be the same, and you'd be employing more people and you'd be giving them a livelihood. But you're using that robots instead of that because it's cheaper for you, not because it's better for them.
Exactly.
So
Yeah, that's a good point.
that's a balance. But that's again, once
Yeah.
again, something human. That's a human error in robotics.
Yeah. Let's take now some of the questions and comments. Now is the moment of the Q and A's. Anyone have a question for Sahil Kumar, so he can answer? I have one here. It's not a question; it's a comment. I'm gonna read the question and the comments. So, but I have one here that is from Jai Gupta. I'm
Hmm.
gonna show it to you on the screen. You can see it.
Mm, right. Yeah.
Yeah, I'm an undergraduate student currently pursuing a BTech focus in mechanical
Hmm.
engineering from NIT in India. So
Hmm.
you have a comment for that?
Hmm. That's great. That's great. If you plan on doing robotics, then that would be a good place to hop on from into robotics from mechanical. I knew a friend who got into robotics engineering from mechanical engineering, and well, it was mechatronics, so it's mechanical plus electronics.
Okay, great.
But I would say if you're a mechanical engineer right now and you want to get into robotics, then also also study electronics, not just electronics, but robotics in general right now, because we have mechanical part is there in robotics, but there's also a lot of electronical. There's a lot of not electronics, I'd say, just coding, algorithms, coding, linear algebra, stuff like that as well.
Oh, great. So he's talking about here about ROS. He's saying in a comment that he's pursuing a career in robotics. That's the same guy, Jay Gupta. So we have here another one that the name is Ambrish Paskaran. Can you talk about Fusion 360 versus SolidWorks? Do you
Well,
have experience with Fusion 360?
No, I don't have any experience with Fusion 360, but I have seen other people using it. And I'd say that, I mean, the only difference that I've seen so far is the Fusion 360, you can render the things better. But if it's a mechanical, it's an AutoCAD software, then they should be very similar in that sense. Because SolidWorks and Fusion 360, like essentially these kind of softwares, they are very mechanically, they can get very mechanically specific. Like the screw holes, like there's another 3D modeling software called SketchUp, which you cannot make screw holes in because that's for architects. So they can make buildings and they can make, beautiful landscapes and views in that, but they cannot make mechanical components in that. So I cannot comment. I'm not sure what Fusion 360 does to that point, but I'd say definitely
They're
give that a try.
similar, like similar in
It
the.
is similar to SolidWorks, and from what I've heard, it's a step up, but I cannot be completely sure because I've never tried Fusion 360.
Yeah.
But it's a good avenue to try in general. Like I have heard a lot of people prefer Fusion 360.
Yeah, I have another comment here. It's not a question, but I think I'm gonna show it. So, it's like, it's with the other one. So it would be nice to hear about Matlab.
Yeah. So Matlab has a robotic system toolbox which you can download and use. I can actually also put that up. I have some designs that I made in the robotic system toolbox. I can put that up. But it is something that can be usable in Matlab. And the good part about it is it's more of a GUI. You can code, but it's also a GUI in the sense that it's a graphical user interface. You will have a bunch of blocks that you just put together. Like I think it was in Simulink. Yes, Simulink in Matlab. So you can use the robotics tool in Matlab to create robotic systems. You will have control loops, you would have transfer functions, you would have all sorts of things. And that's a good way to start as well. Like you can also have a 3D simulation using the robotic system toolbox. So what I showed with the Army, you can take all those components, put them in the robotic systems toolbox, and make it move via code as if there was a motor there. Right now you can do animations, but it's not as if there's an actual motor there. But using the robotic system toolbox, you can do that.
Great. So there's any other question? There's comments here. I can show the comments. But it's like there's no questions. So you see any other one? You can see the screen on your
Yes,
side?
I can see. I really like the conversation.
You want to answer? Yeah, you want to show any of those and answer them? There's comments.
Right. I'm looking at the latest conversation between Miss Yoji and Kieran J. And
yeah, they're talking
exactly.
about robotics.
That's completely true. And that's exactly what we were talking about. Like you have to make it safe.
Yeah, it's like this one, the first one.
Yeah, it was required much more money than the robot. It's terrible to hear so many people discredit robots as a pathway to future destruction. Absolutely. I mean, that's kind of like the, for the lack of a better word, cheap mentality, where it's just, we saw it, so it's got to be true. But when you actually look at it, when you actually research it, they're just going to learn from us. That's it. If you actually have a thorough, proper AI, it will learn from its surroundings.
Yeah, here's another great comment like he made there.
Oh, absolutely.
Yeah.
Absolutely.
Great
Even
comment.
if you look at not just robotics, just in general, where technology can take us, it's mind-boggling. Like there's this whole concept of civilization levels. And I think we're at civilization 0, I think. So civilization 0 is where you can harness everything that you have on your planet. Civilization level 1, or is it backwards? Okay, well, there's different civilization levels. The next civilization level is you can harness the power of your solar system. The next civilization is harness the power of your neighboring groups, neighboring solar systems. And there's steps for that as well. So technology can take us to that level where we are getting infinite energy from black holes. There's this channel that I even talked to you about, the Quirksart in a nutshell. It's really difficult to pronounce, so I'd say just search in a nutshell on YouTube. And their videos are amazing on that.
Oh yeah, I had a look on that. Great videos.
Yeah, they actually explain things really well. They can get a bit morbid, to be honest. Like they talk about a lot at times about like nihilism and death and stuff. But most of their videos,
it's great information.
It's great information. Absolutely, they talked about this where you can actually harness the energy. Theoretically, you can harness the energy of a black hole without even touching the black hole or going inside the black
Yeah.
hole. And it's really interesting. And yeah, I completely agree. We can go there with technology, but that being said,
Mm-hmm.
for me, there is the human factor that always needs to be there because
Exactly.
robotics, in an ideal world, there's a fine balance between the two. An ideal world cannot be all robots and basically no humans.
Mm-hmm.
Because even in that, for me at least, that's a personal opinion, I guess. It takes out the human error in it, the human factor of it. Like the fact that I make mistakes is what makes me human. The fact that we all make mistakes is what makes our civilization. If we were a civilization of robots that were constantly learning perfectly what our predecessors did and building on that, we would already reach a point where there would be nothing, you know, everything would be perfect. Nothing else would happen. I mean, if
Yeah.
you think about it, even the flip of a coin is only 50% because of the human error in it. If you have a robot in an ideal condition flipping a coin, each time it will land on the same side because
Yeah.
everything will be the exact same. The human error in a coin toss is 50%. The coin toss itself is not 50%.
I agree.
And there's something to be said with that. Like,
A great point.
I think it was this movie, Dead Poet Society. John Keaton.
Oh, that's yeah, great movie. Old
Yeah,
movie, great movie. Yeah,
exactly. Yeah.
classic. That's with Robin Williams. I think he's there.
Exactly. So one of his quotes in that was like that's one of my favorite quotes. He says that medicine, law, engineering are all great pursuits and worthy of commendation, but art, romance, love, poetry, those are the things you live for. And I feel like those come from the human condition, like the
Exactly.
poetry, the art, the love, the romance, all that comes from the human condition
Yeah, that's
because of
things
how
that I
we are.
cannot copy. Like even AI, like
Yeah.
be creative. Like
Mhm.
because you see, like they make like with a robot arm, like do painting, and
Yeah.
they put it like, but it's a copy. But
It's a
it's not like from there is following something that is from the. It's not like put something
Mhm.
else there, and
Mhm.
that's the point that we're not still not there. Like that
Exactly. And
creativity is the human beings can do that extra step to make something else.
exactly. So even with humans, like we are so complicated. Even if we try, we cannot make a robot that can compete with a human. We cannot. We
Hmm.
can make a robot that can learn from different things and keep that in mind while it's doing something. But in general, we are in ourselves so complicated. And I remember having this conversation with a friend one day, and he made a really good point on this. I told him, you know what? Why don't we have like robots as like, for example, in different professions, like in judges, because a judge needs to make a logical, unbiased decision that's completely not emotional. Like I'm saying, okay, you add the context to the situation, but then you may still have some sort of a bias or an emotion. So why not just
Hmm.
replace those kind of jobs like a doctor, a lawyer with a robot? And he gave me a very good response. He said, with the doctors, dude, they spend like 36, 48 hours just in surgery. There are doctors who, even though they have constantly seen death around them, they want their patient to live, and they'll try just about anything. Now, I haven't fact checked it myself, but at least from what I remember, he told me that CPR was discovered because of this very thing, where a doctor's patient was about to die, was almost declared
Hmm.
dead, and as a last resort, they started pumping the person's chest and filling air in their mouth, and the person came back to life, and that's how CPR was born. I don't know
Yeah,
if that's true, but that does sound something like something like a human would do, because we
yeah.
can
It's like
know that it's not possible at all, but we'll hope against all hope that it's somewhat possible.
no, it's like now we're talking about movies, but I Robot,
Hmm.
that the
Yeah,
Will Smith. So Will Smith, that there's a part that he's like saving a kid, but the robot prefer like
the logical.
saving him because
Yes.
it was in his mind, like in the program, like the percent to live to the
Hmm.
other one. But he said like it was a percent. But in that moment, if the human like react, like there's a percent, and maybe can live. And
Yeah.
there
Yeah.
can be a possibility there, but
Yeah.
a
Yeah.
robot or an AI we don't see it because it's only see like in the program. Okay, no, the percent is not there. It's gonna die.
Mhm,
So
mhm. But I'd say there's also some credit to that in the larger picture because, to quote Spock from Star Trek, my mom made me showed me all those Star Trek movies when we were kids, and I love her for it. Another
Star
reason.
Trek, yeah. No,
So
everyone, like, there's a lot of people that love Star Trek.
yeah, Spock. One of his favorite lines for me is the needs of the many outweigh the needs of the few. So there's that dilemma, right? Like if you're on a train and there's two tracks, one has only one person on it, one has five people on it. Which side do you go? And you cannot stop the train. And so there's that dilemma that at that time a robot will make the logical choice that will benefit most people as compared to few. But on the other side, if you have a human in that situation, they may be able to figure out a new thing just out of plain desperation. That no way am I letting even that one person die. Maybe they just take the train off the tracks entirely, or just run out the train and take out the one person on the left track and then move on to the left one. Trains are pretty slow, so you can't do that technically. But that's the human part of it. Yeah. You give the same thing to a robot, they'll just say, "Oh, go over that one person, stop the five people."
Yeah, and what we're talking now is like, is that line, and that we're going to find like ethics and the part of like implementing robots and AI in society. So, and that was going to be a battle like forever. Like people will have their point of view and the other ones. But I agree with the point of view that you're putting there, and yeah. But in the other parts, you spoke on like, oh, there's another question here. So let's take this question, and I think we have an hour and a half. This is supposed to be 45 minutes. So I think I'm gonna do a second part of this conversation. Maybe let me show you the question. So do you have an opinion on Boston Dynamics and their work?
Yeah, absolutely. I mean, for me, the things that Boston Dynamics is doing is really, really cool. And definitely what they're making is, I mean, from an engineering perspective, it's really interesting. But from an entrepreneurship perspective, it's like they've made some really amazing things. But if the applications are not there, then it's not something that you can commercially sell. That being said, I mean, the intricacies that go into making a robot that can do flips, making a robot that can dance, it's beyond complicated. It's very complicated. And the most beautiful thing about engineering for me is that as an engineer, you're stepping on the shoulders of giants who have worked their whole life to create something that, when you look at it from the outside, it's very complicated. But when you zoom in, it's so simple and so elegant that it's just beautiful. I'll give you an example.
It's like Spot. Spot is the other one. They have Boston Dynamics. Spot, right? That's the name of the dog.
Spot is from Boston
Dynamics too.
Yeah. So even the most basic thing, let me show you an example. Let's say, so this is what I use for my 3D printer to pry the prints out, and it's fun.
Yeah, you can find in Home Depot.
Yeah. And I also use it for flipping pancakes when I don't have So, but the thing is, for us, if I tell you, can you move the rope? Can you move it like this? Right? You can do it, no doubt. But in general, if you take a very basic manipulator that's only connected by motors, here's what it will do. Like that, right? There's two problems with that. One, that's not what I ask you to do. And two, if you're stopping all of a sudden, then the motor that's actuating this joint, that's stopping it all of a sudden, it will eventually break. It will go bad. It will mess up. So there's one example that's called the cubic spline trajectory. That's something that I put in my project here as well. So it's essentially a trajectory can be generated for the robot to go like this, like this, like this. And trajectory is a word that sounds really complicated when you hear it for the first time, and the cubic spline trajectory is even more complicated. But it's fairly simple. It's very simple. The whole point is, I tell it, okay, my velocity and my acceleration for this joint should be 0 here. Acceleration should be 0 here. It should be 0 here. It should be 0 here. My velocity should be in this direction, certain value, in this direction, certain value, and go like this, and then like this, and then like this. So I am just taking a small, very, very, very small sliver of the linear algebra that goes into robotics. But in general, that's a concept that I just put in, I want the accelerations to be 0. Okay, that's how I'll make it. So it will try to make sure that the acceleration is 0. So when it's coming closer here, it it will automatically adjust the speed it is at to make sure that the acceleration here at 0 and the velocity at this point becomes 0, and then comes back, and then goes forward and comes back. And so much of that work becomes automated once you understand how the physics behind it is working, that you just have to type in a bunch of numbers, like they show in the movies. The coders and the engineers just type in a bunch of things and press enter, and everything works out. That's all you have to do. That's all. And it's very interesting in that sense. So what they're doing,
the Boston Dynamics.
Yeah. Even if you want to check out a very basic version of something like that, I'd suggest to the people watching as well, go online, look at self-balancing robots. It's a problem that's constantly used in competitions. It's constantly used everywhere. And they're very simple projects that will explain to you how the complexities can level up when you're making bigger and better robots or different robots.
Nice.
So, yeah.
Yeah. So I hope that answered your question, Kieran. And I want to now close it here because it's 2:31 now. So we took a lot of time here, but I love it because there was a great conversation that we had about all topics in space robotics and your projects and your background. And I like these conversations be like this. Like we have some topics, but inside of those topics, we can talk about other things. And at the end, we can give people something like they can learn. What we are going to do is like in the description, we're going to add all the links that of the project that you want to share with the viewers and all the links. So we're going to add that in the description of this video on YouTube. I want to thank you again to be my guest for this episode of Replica. And it was great for people that is viewing this. Wait for more because I'm going to bring all the robotic software engineer, robotics engineer, AI engineers. So we're going to talk. I have many topics to go on with the other guests that I'm going to have with
it was great being here, Miguel. It's really fun to talk about robotics engineering, and especially talking with you because most of the time we just agree on most things. Unless we don't, and then we just don't.
No, and we know each other like for a year now, right? So it's funny because I want to say this to the viewers that when Replica start at the pandemic, like it was inside of the pandemic, Replica have like 1 year and something like that. So in that moment, when I started going with this project and I started knowing people like yourself and having all this point of view from all the part of the world. And it was nice. I like this project took me to have like you, like a new friend that have so much like knowledge in robotics engineer and we can share ideas like we like all the conversation we had before, like. So thank you again. I hope like this is the like all that project of Army. I want to see like when you have all this project complete and how you apply and all that. I'm going to bring you back for another conversation and to know more about what other things that you have been doing. And thank you again. Thank you for being here.
Thank you so much. It was great being here.
Share the information. Thank you.
It was great talking to you.
Thank you. Have a nice day. Bye bye.
Thank you.
Thank you, everyone. Bye.
Bye bye.